Hi. Welcome, welcome. We'll start soon. Here. Hi, fine, thank you. Okay, let's start. Let's do something positive. Yeah. Something positive. Really no one. Oh, someone join us. No, they are language students. Okay. The blackboard waits for me. And waits for what's in my plan? 1 second, I'll explain. What did we solve in our previous lesson? We have tried different networks, and all the time we solved the same. While signal is harmonic, sine or cosine, everything much simpler, isn't it? No distortion, everything easy, yeah? At the moment we switch from nice harmonic signal to something different, we see distortions and something not so, something wrong there. See? Need to do something. And one of the idea belongs to Jean-Baptiste Fourier. Fourier asked quite a simple question. Can I substitute something complex where I don't have an easy way to operate, I don't have enough tools, with something more familiar, easy, or closer? Can I substitute something non-harmonic with harmonic? Idea, at first, in terms of signal theory, I have a periodic signal, and I would like to substitute with a sum, say starting from 1 to infinity, AI, Fi, set of functions. These functions should be easy to calculate. For example, can I have a set of harmonic function like cosine, sine? Can I have something easy? Something what easy to integrate, easy to take derivative, something easy. Sounds interesting, isn't it? But we need to answer a couple questions. First, what means easy function? Can we define some requirements on that? In reality, if we take a closer look, this idea means what original signal will be represented as a function of functions. Remember research figure? Signal displayed as a function of another signal. Yeah? Here we will be in reality we are building something like system of coordinates. Cartesian or Descartes coordinate system. What do we need to define for Cartesian coordinate system? Let's say x, y, z directions, yeah, and unity 1 meter, 1 centimeter, 1 inch, something. We need to define unity and directions. And what is the name of unity vector?
IJK. IJK.
Real?
Do we call it like this, for example?
No, I don't know. It's in which system?
I think it's in Cartesian. Like
In Cartesian system,
IJ.
Something interesting interpretation for us, x, y, z, or real, imaginary, also will be Cartesian system.
No, I mean we can call this
Yes,
unit.
we can create system like this. Yeah?
Yeah, I mean this unity, one unity. We can
One,
call it,
yes, one unity or it's or unity vector.
yes.
One of y, one of x, one of yes, someone may call but not to confuse with integer. I know in our tradition we use these two IGK for integers. But also, no problem, we can define them as unit. What's the key about these vectors? They are 100% independent. And they are orthogonal. Yeah? Is that what? Orthogonal. Orthogonal vectors. 90 degree, 90 degree. How it will be? 90 degree. For functions. To create a kind of it's a coordinate space, we need to ensure what? They are independent. Is zero. Some scholars call it zero correlation, absolutely independent function for each one from 1 to infinity. From 1 to infinity. This is called, if we can find a function system what fulfills this covenant, we have an orthogonal system of functions. Problem, but there are not so many of such systems. But we are dealing with periodic signal. If we can ensure what one period fits between some T1, T2, it's okay to live with this covenant, with limited or within limited time space T1, T2. We only need what? One period of time, because we have periodic signal, is less than T1. And everything will work. Our magic will work only in limited time range, but it's not a problem. Moment one, we need system of orthogonal function. But that's not all. See? We have, I don't know. No? We have periodic signal as a function of time. We can decompose it as a set in orthogonal function system. F1, F2, F3, and so on. But it's a direct transformation. We will get some results. We will get something. We need it. It's useless to have million crypto dollars until you can convert them into real money. We need a backward transformation. We need to be able to get our results back. And to do so, there is another covenant. Base of transform should be unity. We need to ensure what? Integrate infinity fi squared gives us 1. At last, T1, but we need this for all functions. We need a unity base. Otherwise, inverse transform will be deforming or crippling. The second, condition is easy, because if you have an orthogonal system of function, you can always use so-called Norman factor, being 1 divided by square root integral from 0 to time. You can do it like this. Fi square of time d time. Who sleeps longer?
Professor,
Yeah.
as I understood, to work this in this condition, if T2 minus T1 is greater than period, then it works.
Yeah,
Otherwise it doesn't work.
Since all this trick at this point is defined for periodic signals. Periodic signals repeats every period.
Yeah.
If I can perform this trick on one period, it's enough. Then I can just, stamp next, next, and next. And if my magic starts here and ends at 12 o'clock, if I can perform all calculus needed from the start of magic till the 12 o'clock, it's okay. It's enough for me, if I deal with periodic signal, to perform calculus on one period. This will set a limit on me. This will set a limit. As it is, it will work only for steady modes or regimes. If I perform calculus for one period, it's okay for enforced on steady regime. But I will see problem if I would like to start with dynamic. I will need to sliding transform, something like this. I'll show how the dynamic calculus, transient calculus are performed.
And Professor, can you tell us a little bit about this Kn?
It's a norming factor. See, for transformation I need an orthonormal system. But I can convert any orthogonal system of function into orthonormal with a set of such norming factors. That moment I need to start with orthogonal system of function. I need set of function. They should be fully independent. Okay. I don't know how in your country. Here, each school has a math class, course of mathematics. And in each mathematics class, on the wall hangs this thing. Cosine, sine, 3 by 4, and 3 by 4. Something familiar?
Yes.
Unity circle. How I hate it.
In trigonometry.
Yeah. And what do we see in unit circle? When value of cosine is 1. What's the value of sine?
2 kp. It means like
yeah.
Yeah.
But when we have 1 at cosine, what will be at sine? 0.
0.
And opposite, when sine is 1, cosine is 0. What about x and y? Something close?
Can we?
We need system of coordinates, base for coordinate system. Sine and cosine are orthogonal. They really form a 90 degree angle. Here, classics of the classics. Orthogonal system. Okay. Let's do it in this way. F0, 1 divided by square root of the period. F1, 2 divided by period. Cosine, double P divided. F square root 2 divided by period sine double P divided by period time F3 square root 2 divided by period cosine of double P and so on. Sine K double P and cosine K double P. Classics of orthogonal function systems. This shows a set of orthogonal functions. This is base for nice decomposition in space of orthogonal function. This is very nice. But there is another problem. Coming back. I said what my periodic signal can be represented as sum of A key F with this is square set of orthogonal functions, for example, my sine and cosine. And what about factors? In each receipt, we can see two parts. What and how many. To pass an exam, prepare a magic with one hand banded hand, two bats and 7 snake teeth. We have what? Hand of the hand bandit and two dead snakes. And how many? One hand and no, two snakes. In each receipt there are two parts. What and how many? How many functions should I use? How many of sine? How many of cosine? How many of double sine? How many of double cosine? How many? Or and here is the bigger question. We have our signal, we have our row. What I'm doing, FK. In theory, they should be equal, yeah? In reality, row of limited lengths will be somewhere within, so, something. Question. We need set of factors to make this row close to our signal to make row close to our signal as possible. But here is one not obvious moment. We need to define criteria, close or not close. What is criteria? What is how can we evaluate difference between signal and row, or let's say quality of representation? What will be our criterion for difference? Fourier selected kind of difference energy. It's minus infinity to infinity minus sum a k starts from 1 to infinity f square that's what Jean-Baptiste Fourier chose. This one actually is a square of Euclid norm. If you would like to go deeper, it's a square of Euclid norm of difference. You may say, but it's proportional to the energy of difference. This criterion, it's a good criterion, but it has its limitation. In situation, I don't know, like this, signal some small kind of spikes with large amplitude but small energy will be ignored. This criterion automatically sets so-called average, converge in average or average correspondence. Law created basing on such criterion will be close to signal. But this criterion minimize energy of difference, not maximum divergence. Small spikes will be ignored because energy of such spikes is low. Anyway, to find factors, you need to solve a system of equation. Zero. You will need to solve such system of equation for any criterion. This will give you best set of factors for your criterion. In case of Fourier, it is integral. You can do it from 0 to period, signal, In case from how Fourier defined it, this formula will give you best A, meaning closest. But what kind of closest? Closest with minimal difference energy. Closest in average. Whoa. So, returning to, we deal with cosine, cos double P divided by n sine P, our set of orthogonal functions. To simplify life, norming factor is joined together with A and rho is written in form. Now is C0 by half. It's in electrotechnics term DC component plus sum, the K starts from 1 and ends at infinity, of cosine double P plus SE sine cos double P Here is the classic form of Fourier rho with sine and cosine component. Substitution of any periodic signal near any. There is one moment I will write. Substitution of any signal near just possibly any periodic signal with limited energy with a set of harmonic signals, sine and cosine. I can rewrite this in bit compact form. As C0 divided by half plus sum distance from 1 to infinity AK cosine half omega plus TK. Here, AK is the square of SK square, SK square, omega double P divided by period, and TK will be minus R times SK divided by CK. What do we see? Blackboard with white madness. No, it's not a white madness. This thing tells us what my periodic signal can be substituted with one DC component and set of AC, ideal AC components with frequencies. Base frequency, double frequency, triple, and so on. My signal will be represented in space where one coordinate is DC and other coordinates are ideal AC voltages on currents. Okay, where will I get this? From 0 to time cosine double P time and sine factor divided by T 0 to time sine double P times integrate in time. Here, maybe write them. They are basics of Fourier transform. How to get all these Fourier factors. Here is your way from our time space to space of ideal harmonic signals. You can substitute your periodic but some kind of strange signal with the set of ideal harmonic signals with this nice pair of integrals. It's the help of this nice pair of integrals. One.
Professor,
Yeah.
can you shortly explain the term orthogonal signal?
Orthogonal function.
Yeah, orthogonal function. What does it mean?
In very short, set of orthogonal function is kind of box of functions where each function has a zero correlation or absolutely independent from others. Orthogonal term. Function 1 is orthogonal to function 2. This means what there is absolutely no way to find a correlation or depends between function 1 and function 2. And this allows us to use them as a base for coordinate system. We can create a functional space where this function will be used as kind of rail or this coordinate lines.
For example, as an example, we can take sine's function as an orthogonal function.
Sine is orthogonal to cosine. There is no orthogonal function, simple orthogonal. Orthogonal, it's to something. It's a mutual, how to say, quality. This orthogonal to this if they are absolutely independent. And there is no way to describe this as a function of this. Or zero correlance. If we perform a correlance calculus between this and this, we should get zero. If not zero, they are not orthogonal. Vertical is absolutely independent with horizontal. Width is independent with the height. And both are independent with depth. Yeah? This one? So, I can write what? My signal is C0 by half plus somewhere from 1 to infinity AK cosine T omega t plus T T. I can write in this form. L. What we knew? Euler's formula. Euler's formula is cosine alpha can be expressed a power alpha minus a power minus y alpha divided by half. Y is square root of minus 1. Yeah, something familiar from complex mass. Euler's formula.
Yeah.
I can apply Euler's formula to this cosine. I can assume alpha as T omega plus Tk. Omega is radians per second, T is in seconds, so results will be radians, and phi, angular shift, also in radians. If something is measured in radians, possible it is an angle. Yeah? Okay. So what will I get? This is fine, this is fine. Come here. I will be able to write another form of Fourier rule. And it is, I can introduce a complex amplitude for my harmonic, a power K. My rule will be something like this. 1/2 sum that K starts from minus infinity to infinity. AK a power what? Why? I can immediately do this. I can do it in this form. This form is a bit strange. It introduces negative frequencies. Original one, base frequency, double, triple, and so on. Here, negative frequency. Alright. Nothing extremely. We have a key describing rotation in this way. K omega. There exists a mirror. A minus k being a complex conjugation. And it rotates in opposite direction. In complex mass, there is idea. I have x, a plus dot b. A, b plus 1. There always is a conjugation, or kind of mirror. X conjugated, a minus dot b. It's minus b. Minus phi. So conjugated is like mirrored towards real ox.
By multiplying these two, I think we can take whether
if you multiply complex with its conjugate, you will get double real part.
Is it like, once I heard it gives something like maybe square
of real part?
Yeah.
What? Square of inverse. A plus dot b multiplied by a minus dot b. What you will get? A square.
Yes.
AB minus yod AB, they disappear, and yod B squared. Because square of yod is minus 1, there will be B squared. So you will get A squared plus B squared. If you sum them, you will get double real part.
I got it. Yeah, if we multiply these two, it gives magnitude of this vector.
Square of magnitude.
Yeah,
not
square,
magnitude, but square of magnitude.
of magnitude.
Okay. So, there's one thing. In Fourier rule can be shown as only function of real frequency or as a set of two conjugated parts. Real frequencies, negative frequency, and they are conjugated. It will be something symmetrical towards imaginary. Awesome. Yeah, this allows me to write what? To write formula for complex factors. It will 2 divided by period minus period by half, a power minus dot p double p divided by period time. Formula, another formula to get complex Fourier representation. This shifts me from, shifts, opens transfer gate from our time functions into set of frequency function. Result will be function of frequency. This one transfer from time to or equals to t omega. Backward. For example, I can use symmetry, so it will be a0 by half plus a real part of sum starting from 1 and to infinity, ak, a power your k omega t. Yeah. Boom, boom, boom. All this confusing, isn't it? Confusing?
Yes.
I need an example. Can we do something what I can test with my finger? I don't like to test voltage with my finger anymore.
Professor, I think this one is confusing because we can't visualize it in our mind. So
one moment we will try.
Yeah, I have a personal question. How can we visualize not only a Fourier transform but complex plane, complex numbers? I really want to visualize.
It's a serious problem. Something I can draw in three-dimensional, assuming imaginary part going like this. I can draw a magnitude of complex function, but sorry, true complex world, it's not existing.
Yeah, we can't visualize it here because board is two-dimensional.
Yeah, I can try to create a three-dimensional drawing for something.
I mean, do you know any kind of program or something tool in laptop you can use to visualize?
You can use MATLAB, but limiting is not in software or hardware or something. Limiting point is what complex world is imaginable. It's thing not existing here in our reality. It's only play of mind. It's an abstract thing. So you can only derive something in our... okay, let me show an example.
Okay.
Example. Let's take something rectangular. Time. Here will be my signal. T by half minus t by half. Oh. 0 and magnitude and here minus. Can we take something rectangular? We saw it a lesson before, yeah? What will be much explanation for this?
You have to sum a lot of functions in different frequencies.
Maybe I'm creating some space for myself. My signal can be written as minus e double plus 1 time double n plus 1 sorry, t by half, and here should be t by half. Yeah, now it's correct. And when double m t by half time double m plus 1 t by half. Oh, here should be, here m is an integer. Here is mass representation for meander-like signal.
Professor, let's make quick explanation. M is integer for how to say?
This, well, for example, here m is minus 1, m is 0, m is 1, here next to m will be 2, and so on. At this point corresponds to minus 1, 0, 1, and so on. Now let's try to perform Fourier transform on this. So, complex amplitude of harmonics will be double A divided by Fourier. Okay, by period. A power double P. Base Fourier formula, in my case, double A divided by period. Minus P by half to 0. A power double P time minus integral from 0 to P by half A power minus K double P divided by time times. Oh, here it is. I just wrote Fourier transform formula.
Also dt.
Yeah, this one should be, of course, in time. Funny, funny, funny. Now let's see. I wrote it on during the meeting of financial committee, so it bit smells like accounting office. Financial Commission of Sinai. So what will I get? I will get something like double E divided by double KP multiplied F dot K double P starting from 0 and by half minus A power minus dot K double P time minus P by half to 0. Oh. This will give me E divided your KP minus F your KP plus F power dot KP. As I corrected, remember Euler's formula, this one is nothing else than a double cosine of Kp my block S double S divided by your KP multiplied by 1 minus cosine of KP. Oh! Accounting. So, my signal can be substituted with sum of what? Of this. Okay, let's try to 1 second. I will write I can use this. I can write now. Take a look. AK is double A divided by KP. Second 1 minus cosine KP. Complex. A0, DC component. What's the cosine of 0? What's the value of cosine of 0? 1. 1 minus 1? 0. Equals to 0. Okay. A2. What's the value of double P cosine? 1? 1 minus 1? 0. 0. Any A double P will be 0. There will be no number 2, no number 4, no number 6, no number 8, and so on, and so on. Okay. Fine. No DC component and no odd components. Not even A1. Double A J P 1 plus 1, yes, equals to 4A divided by P A power minus P by half. Divided by J is the same, but turn vector back at 90 degrees. Same way, A3 double A divided by 3P 1 plus 1. You agree with 1 plus 1? Cosine. Cosine here.
Minus 1.
Minus 1. Double P. Full circle plus P. Half of circle minus 1. Minus 1 minus minus 1. 1 plus 1. So we will get here 4A divided by 3P A power minus P by half. And so on. For number 5, we will get 4A divided by 5P. Now I can write my rho as a time function. So I can substitute my signal as 4A divided by P multiplied cosine of omega P by half plus 1/3 cosine 3 omega t minus p by half plus cosine of cosine, wait 1 second, 1/5 cosine of 5 omega t minus p by half, and so on, equals to, if we shift cosine 90 degrees, what will we get? Sine. T. What will we get? For A divided by B sinus omega t plus 1/3 sine 3 omega t is 1/5 sin 5 omega, and so on. So equals to 4a divided by b sum I from 1 to possible infinity sine of double I minus 1 divided by minus 1. Here it is. What is it? It's the composition of rectangles into set of harmonic signals. Can draw a diagram. Magnitude of AK, frequency 1, 1/3, 3, 1/5, 5, 1/7, and so on. My signal represented as a function of discrete frequencies.
So in frequency domain, rectangular, for example, in time domain,
it's rectangular.
Yeah, graph of our function is rectangular.
In frequency, what rest weight function, like like function of discrete frequencies.
It means like it is something looks like exponential, but minus.
No. 1, ideal, nothing around. 3, 5. If you represent this function, it will be discrete on discrete frequencies. Double p divided by period, triple, fifth. Really, like this, on discrete frequencies and nothing around. No exponents.
So, the main function of Fourier transform is sum, how to say, sum all of these different functions and make such kind of square function, or just
Wait a second. What do we have?
So
It should be 300. Okay. harmonic signal with frequency 300 Hz. Yeah? What my formula says? What a rectangular signal is 1 of base frequency, 1 plus 1/3 of triple. Yeah? Triple frequency, 1 second. Q. And angle should be 0. This is 1 plus 1/3. Triple frequency. Sine, yellow line is sine.
Wait.
What this line is sine?
Yes.
It's a sine of 3 omega, 1/3 of sine 3 omega t. One moment. For A divided by P multiply sine omega plus 1/3 sine 3 omega plus 1/5 sine 5 omega blah 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 so on. Spectral diagram 100% at 1 omega, 33% at triple omega, 20% 5 omega. Now this yellow line is now this component.
This one is the first one.
Is the first one. Both together. 2 tones. Can you hear? 2 tones. Is it sine? No.
No.
1. A bit more. 4.
This is
1 second. 1/5 of 5 omega. 1 plus 5. 1 plus 5 plus 3. Is it close to rectangular?
wait.
It comes closer and closer. Only base frequency, third harmonics added, fifth harmonic added. Sorry, 7. It should be here. You see, it comes closer. Where is my... What I have? Circuit.
Professor, I want to ask you something about this one before you clearing it. Like this one is sinus t sin 1/3 sinus 3 t. This uh, all this one given by formula exponent e by I something t. Like
I
this
omega.
one, yeah. This gives all these ones such kind of.
We have universal formula. But complex amplitude of harmonic is 1 divided by k, a power dot k omega t.
Okay.
Fourier transform.
Yeah, and like not writing long all this shit. Just we use e powered by I. Like
see, we need to go this way. We need to perform this integration. We can do it numerically. I will show how to make machine do this work. Anyway, you need to perform a Fourier transform. Second, what's here? One coil, one capacitor. Circuit of small capacitor. Ground, output, input. This one is 15 nanofarads, and coil is 4.11 milliamps. Let's try small experiment. I will put my S from T here. This will be our yellow line. And this one will go as our blue line. Go. Maybe use a nice junction box. Come here. You go here, you go to the output, you come here. The ground wire. And can I have more ones? This is signal. Should arrive somewhere at this one is fine. The adjustment is needed. This one is fine. What would you say?
Is this blue one ST?
Yeah, blue one is output and yellow is input. See? People, how it's react to the frequency. Scale 5 volts per division. Input 3 volts, output 7.5, effective frequency 1922, 19 kilohertz. How would you explain this? How would you explain this? We have rectangular input at frequency of 9 kilohertz, and we have nice harmonic output. Any idea how to explain it? What happens?
Professor, maybe this is because of this capacitor, second capacitor and coil cancels out like resonance, voltage resonance, and
cancels is a wrong word here. Cancels. No one cancels.
Maybe it's fluctuating when it's going like high.
Why do we see output sign with high amplitude? Where we are. So, this is resonance circuit. Yeah. Resonance of current. I can write, if this is point A, imaginary part of conductivity A, ground, should be 0. This is equation for resonance of current. This will give me a resonant frequency. You can check with for resonance frequency being 1 divided by square of LC, equals to approximately should be approximately 19.5 kilohertz. In reality, coils be different, so I got 19.2. So omega, I can write a transfer function. If this is, let's say, x and this is y, transfer function I can draw. Transfer function for this circuit is something like this, with peak at somewhere around 9022 kilohertz. This is clear? For my circuit. You had a resonant circuit in your electrotechnics theory, yeah? Yeah? Resonant circuit.
Yeah, we had.
Actually, this thing works as a band pass filter. Not the best one in the world, but it's a band pass filter. It suppresses all frequencies except area around 90.22 kilohertz. Next step. This is clear?
Yeah.
What's on the input? Rectangular signal is 1 at 1 omega, 100%, 33% at triple omega, and 20% at 5 omega. What's going on now? What's the frequency of the base? 19.2, yeah? See, it's 7, 16, 22. Transfer function of my band pass filter. What's a bull line in reality? Should be 1 omega t filtered from my signal. Can you agree with this? Base harmonic. Can we check it? Huh? To make nice, I can switch second scope. If it works. Bit corrupted. Okay. This one is good enough. Can we check it? How? What did I switch off? Base frequency. Now only 3 and 5 remain. I can check. I can, no 3 omega.
Yeah.
No 5 omega. Anyway, you see, changes nothing. So it's really a base frequency. Yeah? You agree? Can I order measurements different? Measurements. Channel 1, channel 2 frequency, both equal. You see it? So it's a base frequency. And on remote, yeah, it's okay. Visible. If you can change something, one moment. If I can change, I will change. Need an angular adjustment. What would you say about this preset?
So you change
Frequency.
I think not only frequency.
Frequency. I've
Yeah,
changed frequency. And now, super generator. Input frequency 6.4 kilohertz, output 19.2 approximately. What's going on? Can you explain? What's the ratio between frequencies? Output, input against output. Or output,
Gain, is it?
output against input. What's the ratio of frequency? Free? No? So, any idea what do we see? I said rectangular signal contains 100% of base frequency plus 33% of triple plus 20% of fifth harmonic.
Then it will be 3 output.
3. So ratio 3. Is it possible that blue line is this third harmonic? This component 3 omega t. Frequency triple. Six 6.4, 18. Approximately triple.
Yes.
Yes. Its sign blue line. And look what happens if I disconnect plug number 3. Disappear. I can disconnect plug number 5, no change. I can disconnect base, no change. So it's a real number 3. We are now in situation that my bandpass filter takes out from all from set of three frequencies 3 omega time. More. What about this? What do we see?
1.5.
5. Ratio 5. And this is component number 5 filtered out by my bandpass filter. In reality, this rectangular signal is a sum of base frequency, triple, and this is 5 times. With the help of bandpass filter, I cut from the spectrum only offset of frequency spectrum. I cut from the spectrum component number 3, which is 5 times, 5 omega t. Blue line is 5 omega t. Now you agree with Fourier idea. What rectangular signal, Fourier-based idea, rectangular signal can be substituted with 100% of base frequency plus 1/3 of the triple frequency plus, well, 20% of 5 time frequency. Yeah? Can you agree with this? Harmonics. Fourier law opens for us interesting way to solve complex current problems. We can substitute one, for example, rectangular current with the DC component and set of ideal AC components. Perform your calculus on each one. If your network is linear, you will be able to get a result as an inverse Fourier transform of the resulting set of Fourier vectors. A1, A3, A5, A many are Fourier vectors. Perform inverse Fourier transform and you will get time series. You will get something in time. You come. This small demo. Actually, it's a demo to the god of demos. .400 hertz at Z and eight simple research figure. Hey. Very simple research figure. Connect this, connect this. One moment. Here is my signal, simple research figure. Now what I'm you know what this? Research figure, same. Horizontal is a pure sine, but vertical channel has this voltage. I will, sorry, I'm lazy to go for second. Come on. This voltage. It's a base frequency plus double plus second harmonics. I'm changing phi2. I'm changing angle of the second harmonic. Quite interesting research figure. One plus three. I have added third harmonic to my signal. Here. Here how my signal looks like. And here is research figure. Base, it's a combination of first and third harmonic displayed as a function of pure sine. Называю. More wires, it's a gut of wires. So God. Bars. 1 and 3. First and second. Fourth. Number 1 and number 4. And 1 and 5. One, 3, 5. Such research figures it's not precise, quite rough. In times where all my cares were in place, this was used as a route technique to perform a spectrum analysis, to understand what components are in. Strange and unusual figure. You see, it rotates. It's too big, but rotates. It's a flat figure. You think it rotates because it changes with frequency equal to slight of frequencies between lower and upper generator. Okay, I think it's enough for today.